think about like economics and those types of majors, they still have to have calculus, and it's because of the relations here. When we're solving our maximization problems, kind of the steps that we're going to go through, and we're not going to necessarily label them 1, 2, 3, 4, 5, but we have to figure out what we're trying to maximize or minimize. You know, I'm going to find the maximum revenue, or the minimum cost, or the maximum distance, something like that. You have to have everything in terms of one variable. So, you know, if I'm talking about a rectangle, I can't call the sides x and y. I have to get it in terms of one variable so we can work with it. We'll pay attention to our domains just so we can check our answers and make sure our answers are reasonable. Then we know if you want to maximize or minimize something, where do you have maximums and minimums? At the critical points, right? So we'll do our derivative, find out where I have critical points, so where the derivative is 0 or undefined, and use that to find your maximums and minimums and answer the question. All right, so let's take a look at this example. I tried to leave you some blank slides on this one so you'd have plenty of room to write. A farmer has 200 yards of fence to construct 3 sides of a rectangular pen. An existing long straight wall will form the 4th side. What dimension will maximize the area of the pen? Okay, you've done problems like this. You know, we did basic forms in like Algebra 2, college algebra. We did scenarios like this, but I usually gave you different information, so you always ended up with quadratics and we were finding the vertex. We're going to use calculus to solve this now. So I'm going to draw a picture here. We are using this wall for one side, and then we have our pen here. Now if you want, you could call these sides x and y. We know for a rectangle, opposite sides are equal. I only have to fence those 3 sides. What do we know about that? How much fence do we have? 200. So probably the biggest fence we could make would utilize all 200 yards. So what I could do is add these up. 200 is like your perimeter. So if you add those up, that has to equal 200. So we can subtract your 2x. So y is 200 minus 2x. So now I no longer have x and y. I have everything in terms of one variable. If I asked you for the domain here, just to make sure we know what our possible answers could be, what's the smallest x could be? Could it be a half or a fourth? So we'll start at 0. Now we know in all practicality, are you going to build a fence with the side length of 0? No. But we're going to, just for thinking about, I'm going to go ahead and say x is less than or equal. We know it's not really going to equal 0, and we know we're probably not going to build a fence with a side of half a yard long. But we're going to go ahead and just put that there to check our answers at the end. What would be the absolute biggest x could be? The biggest it could be is if this side were 0, right? The smallest is if x is 0, so the biggest would be if this is 0. So that's if x is 100. You couldn't have x equal 200, for instance, because then both of these would have to be 200, and that adds up to 400. Okay, so that just tells me when I'm finding critical points, the only points I can use have to be something between 0 and 100. If I got anything else, I would just throw those out. You could still figure that out if you didn't take the time to find your domain. You know, at the end, when you go to write your sentence, if you're getting a negative side length, then that one clearly doesn't work. So you can catch yourself later on if you don't write out your domain. What am I trying to maximize? Area. How do you find area? Okay. So my area is length times width. In this case, it would be x times 200 minus 2x. Okay, so if I distribute, my area is 200x minus 2x squared. And you've got a blank slide after that if you need more space. Alright. Then, how do I maximize or minimize something? Find your derivative and set it equal to 0. So my derivative, my a prime, will be 200 minus 4x. Set that equal to 0. Divide by 4, and x is 50. How do you think I want you to answer this in the sentence? We don't have to really worry about, is 50 between 0 and 100? Yes, I didn't get more than one answer, so I don't have to figure out which one to pick. 50 is my answer. So I do want you to answer the question with the sentence. I just asked what dimensions. So the fence should be 50 yards by, the other side was 200 minus 2x, so 200 minus 2 times 50, and 100 yards. If I had gotten multiple values for x, how would you tell which ones were maximums and which ones were minimums? Plug them back in. Remember, just like when we did our graphing, we found our critical points and then we made that sign line to decide if they were maximums or minimums, so you could do that. You know, if you wanted to verify this, if I put in a 50, then you do something smaller and something bigger. Plug them into your derivative. If I put in a 0, I get a positive. If I put in 100, I get a negative. So it went from increasing to decreasing, so it was a maximum. So you can always double check that. Okay. Questions or no? The second example I have changed. I printed your notes, but then I changed my example. So just X that out, and I'll give you a second if you want to write this one down. Sorry. This one, we start off similar. We have 1,000 meters of fencing, and with which to build a rectangular corral. So I'm going to draw myself a rectangle. Some of the fencing will be used to construct 2 inner divider fences, both parallel to the same sides of the corral. What does that mean? We're just partitioning this off. Okay, they're parallel to each other. What is the maximum total area of the entire thing? So if I start off calling my sides X and Y, what else do I need to do here? We have to include the 2 in the middle. So when I go to add this up, what will it be? Equals 1,000. Okay, we have to get rid of one of the variables, so solve for one of them. I'll just solve for Y. So divide by 2. So my other side is 500 minus 2x. What would it have to fall between? What would be the absolute smallest? 0. what's the absolute biggest? 250. If you set your other side to 0, 500 minus 2x equals 0, that's 250. Again, you don't necessarily have to write that down, but if I ask for it, you should be able to give it to me. Okay, what am I trying to maximize? Area. Why don't you guys try it from here? See if you can finish it. So area is just length times width. So 500x minus 2x squared. So your derivative would be 500 minus 4x. Set that equal to 0. Divide by 4, and x is 125. So answering the questions, maximum, here I just asked for the maximum possible area. So did I even ask for the dimensions? No, I just wanted the area. So you have two ways. You could either plug this in, get your dimensions, so this side would be 500 minus 250, so 250, and then length times width. Or you could plug your 125 into your area equation. Either way. So do that, and what do we get? Yeah, 31,250. We're in meters, square meters. Because if you go to plug this in, this side is 125. So 500 minus 2 times 125 is 250. So 125 times 250. Yes.
So, I didn't do the x times that.
Mm-hmm.
4x, and I still got the same answer as the first.
So you really, it's just Okay, other questions there? Let's go ahead and look at the next one. Alright, we did problems like this last year in college algebra. I gave you different information, so it always turned out to be something easy to solve, but now we can expand on that. So a piece of sheet metal is rectangular, 5 feet wide and 8 feet long. Congruent squares are to be cut from each of the 4 corners. The resulting piece of metal is to be folded and welded to form an open top box. So you're going to cut out the squares, fold up the tabs, and then we get a box from that. How should this be done to maximize the volume? Okay. We need to find the volume of that box itself, which means I need the dimensions of the box. Do I know how big these squares were that were cut out? So what do I call them? X. They're identical, so all of those are X on each side. Okay, so when I make the box, I have cut off X here and X here. So how much did we remove? 2X. So the length was 5, so now it would be 5 minus 2X. This was 8. So I took off X here and X here. So now it is 8 minus 2. The height of the box. These folds are made on that tab that's left. The height of that tab is what? X is the size of the square we removed. So volume, how do you find volume of a rectangular? Length times width times height. So I just multiply those together. Is everybody with me so far? I'm going to multiply this out. I'll FOIL the 2 first and then distribute. So that would be a 40 minus 10 and minus 16, so minus 26x plus 4x squared. And then distribute my x. Okay, what do I need to do with this? Derivative. You could go ahead and pull things out. I'll do my derivative first and then simplify that. So the derivative of 40x would be 40 minus derivative of 26x squared, 52x plus 12x squared. I need to know when this is 0. So I'm going to go ahead and pull out my greatest common factor, and I'm probably going to reorder this. So if I pull out my 4, then can I put my x squared term first? So that would become a 3x squared minus 13x plus 10. What do I have to do for that inside? Use these factors nicely. So those multiply to 30 and add to negative 13. So factor, and get x minus 1, 3x minus 10. So now a quadratic equal to 0, we just set each piece to 0. Does 4 ever equal 0? No, so we ignore it. What makes x minus 1 equal 0? And 3x minus 10? Okay, this one we didn't write down our domain. So that means when I get to the end, I actually have to think through and see which ones are reasonable answers. If I were to let my x be 1, I wanted to find the, as you know, the size of the square. If x is 1, then my sides would be 1 by 3 by 6. Is that reasonable? Yeah. If it's 10 thirds by, what's 5 minus 2 times 10 thirds? It's a negative. Can I have a negative there? No. So that's what I meant when the domain is kind of optional, as long as at the end you're checking to see which one is reasonable. that's okay. So we have our answer. I just wanted to know the size of the squares, so the squares should be 1, and we were in feet, so 1 foot. Any questions there? I am going to jump and do the very last example, and that'll be my last one today. So I want to go down to example 5. Okay, find the point on the parabola y equals 2x that is closest to the point 1, 4. Okay, I'm asking you to find a point. I'm asking you to find an ordered pair. An x and a y. Okay. So I have to figure out how we are going to get there. We know we can't have two variables, right? So I have to get rid of one of these. We know this point falls on this parabola. Y squared equals 2x. Could you solve this for one of the variables? Would you rather solve for x or y? Probably x, so we don't have to have a square root. So I could divide my 2. I'm just going to write that as 1/2 y squared equals x. So my point is really 1/2 y squared, comma y. I want these 2 points to be as close as possible. So am I maximizing or minimizing? Minimizing, because I want them close. What am I minimizing? Distance. Do we know how to find distance between 2 points? Is there a distance formula? Remember the distance formula? From Algebra 1 days? It's just like yesterday, right? Okay, that's our formula. I'm going to use these 2 points and plug into there. So x2 minus x1 would be my 1/2 y squared minus 1, plus y2 minus y1 would be y minus 4. Okay. I need to minimize this, which means I need a derivative. Now, as it stands, this is really messy because we have the square root and then all this junk underneath. Can we agree that if I want the smallest possible square root, that happens if the thing on the inside is as small as possible? So, for the purposes of our derivative, could I just worry about the inside and making that as small as possible? So, I'm just going to write a little note. So that's not always the case, but if we're trying to find the smallest possible square root, that would be the Okay, so we just need the smallest possible thing underneath. So let's just look at this. We're going to use that for our distance. So to minimize this, we just need its derivative. You could FOIL it all out first. I'm just going to deal with it as it is, so I'm going to do chain rule. So 2 comes down, inside stays the same, subtract 1 from the power, times derivative of the inside, derivative of 1/2 y squared would be y, plus over here, exponent comes down, inside stays the same, subtract 1, derivative of the inside is just 1. So if I distribute a 2 and a y through this, I get y cubed minus 2y plus 2y minus 8. So y cubed minus 8, and I want this to equal 0. So add over your 8. Cube root, so y is 2. Okay, how do I find my x? Plug it in. We know that x is 1/2 y squared, so 1/2 times 2 squared is 2. So the point is 2, 2. At this point, you are ready to do these 4 projects. Monday, I will finish this. So we have 3 examples left we'll go over Monday. And I'm going to give you 3 or 4 additional problems. And then all of this will be due on Tuesday. You really need to try to have these 4 problems done by Monday. If you wait until Monday and then try to do all 7 or 8 problems, you're not going to get it done. Okay, so try to get a good start. If you get stuck on something, then come see me, but try to get as much as you